Hello everyone, welcome back to Breaking Code. Today's video we are solving a LeetCode medium problem, minimum operations to transform array into alternating prime number. So we are given with an integer array nums, and an array is considered an alternating prime if elements at even index based zero based even index are prime numbers, elements at odd indices are non-prime numbers. So in one operation you may increment any element by one, or you may increment any element by 1 and return the minimum number of operations required to transform nums into an alternating prime. So we know that prime is nothing but a natural number greater than 1 with only two factors, that is 1 and itself. So to solve this problem, you'll be understanding what the problem statement is. So we are given with an array 1, 2, 3 and 4, and their indexes is 0, 1, 2, 3. So even indices in this are 0 and 2. Odd indexes are 2, 1 and 3. So it even indices, it even you need to have prime number. At odd you need to have non-prime number. So if you don't find prime number at even indexes, you can increment 1 to how many times you want, but it should be minimum. It should be minimum number it should be. So so 1 is not a prime number. So what is the next prime number? You should only do increment, not decrement. So the next prime number after 1 is nothing but 2. So we have incremented 1 here, and here 2, we got 2. So 2 is a prime number, so we need to make it as a non-prime number. So we'll be checking after 2 the next prime number is what. So we'll be checking with 3. Is 3 a prime number? Yes, it is. Then you will be checking with 4. Is it a prime number? No, it's not a prime number. So you'll be taking 4. So you have incremented here 2 times. So you add this 2 to this. Now you'll be having 3 here. We check whether this is a prime or not. So here it is a prime number and the index is even. So if you are having an even index and it should be a prime number, so we need not to alter anything in this for this number. So you'll be moving to the next, and you'll be checking whether this is an even or odd number. So even or sorry, this is prime number or not. So here we got an odd index. So we in the question it is stated that odd indices or should be non-prime number. So here 4 is a non-prime number. So 4 is a non-prime number. So you'll the total numbers we have got is 3. So to solve this in an optimal way, we can do is to write an optimal approach for finding a prime number. So so I'll be explaining the optimal approach to find a prime number. So the first thing, we'll be taking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. We have taken numbers up to 16. So we know that, so we'll be writing those functions here. The cases what we are handling here will be writing. So that is nothing but function prime. So we'll be taking a function. So first thing, if n is double equal to 1, what you need to do? It is a non-prime number. So you just return false. So here 2, so this is completed. So 2 and 3 are prime numbers. So you will be making if n double equal to 1 or n double equal to 3. So these are prime numbers. So you need to return true. So next, this is completed. So you'll be checking with 4. So 4 is a non-prime. Okay. Then you'll be checking with 5. So we'll leave 5 for now. So we'll be checking with 6. So 6 is a non-prime. Then 7, you'll be leaving 7. Then check for 8. 8 is a non-prime number. Then check for 9. 9 is a non-prime number. If you look carefully here, you can find one common thing in these numbers. So 2, 3, 4, 6, 8, and 9, and so on. 10, 12. So if you look at these numbers, you'll have one common thing in this. These numbers are either divided by 2 or either divided by 3. So if you check 2, 2 is divided by 2 and 3 is divided by 3. But you should remove these two values because we have already written one statement and handle these separately. So the next thing you will be doing is, you got 4 here. So you will be checking whether 4 is prime or non-prime. So we can directly say this is a non-prime number. But if you look carefully, 4 is divided by 2. 4 is divided by 2. 6 is divided by 2. 8 is divided by 2. 9 is divided by 3. 10 is divided by 2. 12 is divided by 2. Then next 14 is divided by 2. Then 15 is divided by 2. Sorry, 15 is divided by 3. So if you check in this, we can say that whatever the numbers which are divisible by 2 and 3, those are non-prime numbers. So we can write one case, that is if n mod 2 double equal to 0, or n mod 3 double equal to 0, then you can say that these two are non-prime numbers. So we have written false. Now if you check the leftover numbers here, the leftover numbers are 5, 7. Then you can remove 10, 11 will be left over, 12, 13 will be left over, 14, 15, and 16. If you carefully observe, you can see that 5 and 7 are left. So for this, you will be writing a for loop, and the I will be starting from 5, and I will be less than or equal to square root of given number. So instead of checking till n numbers, we'll be checking only to the square root of n. So this is where we can check half of the elements, so that we will be reducing the time complexity here. Instead of checking till n, then you will be incrementing. I'll be writing this incrementing of I later. So you'll be having this space. You'll be checking if there are 5 and 7 left. If nums of I, the number which we got, if it is divided by I, or if the num is divided by I plus 2, which is nothing but 7, if it is divided by 2, if it is divisible, then we can say these numbers are not a prime. Then at the end, if this is not possible, you can directly say return true. So now we'll be doing a dry run on the given first test case. The first test case is nothing but 1, 2, 3, and 4. Now you'll be checking if I mod 2 is double equal to 0, then you can say this is for prime. First you'll be checking while not equal to is prime. If it is not a prime, you'll be having a count, and you'll be taking the value which you got from for loop. That for will be running from 0 to n, and you'll be taking that number as you'll be taking that num, will be storing that in nums of I, and you'll be having a variable steps. So if it is not a prime, then what you're going to do, you'll be incrementing the number and you will be incrementing the step. When you find that the number is prime, then you will be adding count plus equal to step, and you can add else. This is you should check for non-prime. So the same you can add here. So you'll be getting num, and you'll be having int num as nums of I, and you'll be having steps. So while is prime, if it is prime, we no need prime numbers here, we need non-prime numbers. So you need to increment the number and need to increment the steps as well. At the end you add the steps, and you will be returning the num. So you will be returning the count. So now you are having 1 2 3 and 4. So first you got the variable num, that is 1. It will go into, then the step count for this is 0 and count is equal to 0, and I'll be changing here. I'll be taking num which is equal to 1 and step is equal to 0. So it will be going, this is an even index. If you carefully observe, this is an even index. So we got even index, so it goes here. So you got num is 1 steps and while is prime. So n is not a prime, so it will be returning false, and you have the operator. So it will be making, if you got false, it will be making it as true, and the num will become 2. So the num will be incremented. My bad. So num will be incremented to 2 and step will be 1. Then it will be checking whether 2 is prime or not. So it will be returning false to it. Then it becomes, so it will be returning true to it because true is a prime number. Then here the while loop gets break and the count plus equal to step. So the steps here is 1 and the count will become 1. Now we'll be changing the step and count. Now you got the odd index and the num is 2 and the step is 0. So here you need to check, it should be not, it should not be a non-prime here. It should be prime here. It should be non-prime here. So now you got non-prime number. Now you got a prime number. So it will be going here and it will be checking whether it is prime. Then it will be returning true. So it becomes false. So now it will be, not this. It goes here. So it will be checking. So it will be returning true. So whenever it returns true, the num will be incremented and step will be incremented. So the nums become now 3 and steps become 1. And it will be in the next iteration, it will be checking for 3 whether it is prime or not. So it will be checking for 3, it will be a prime. Then once again you need to increment your num and step count. So your num becomes 4 and step count becomes 2. So after this it will be checking for 4. So here 4 is a non-prime number, so this becomes false and the count will be added. So the step here, step is 2 and count plus equal to step. So count we are already having 2, so 1 plus 2. Now the next element is 3. So at even index you need to have prime. So it will be checking whether it is prime. So it is prime, so it won't become, so count. So here you will be having 3 and step will be 0. So as it is prime, so it goes into the next. So you'll be having the step as 0 and the next it is going to, so here it should be non-prime. It will be checking for 4. Yes, 4 is a non-prime number. Then the step will be 0. So now we got the count as 3. If you check the output here, it is 3. So I think that's it. Uh, so the time complexity of these algorithm will be somewhere around, we are checking for each element, that is n, and we'll be running the loop up to square root of n, but uh, it won't be running every time, because if any in most of the cases, the most of the numbers will be divisible by 2 and 3. Most of the cases will be gone from here only. So we'll be considering it is like square root of k. So the space complexity will be O of n, because we are not using any space here. So, and that's how we solve the minimum operations to transform array into alternating prime efficiently. So if this explanation helped you, don't forget to like this video and subscribe Baking Code for more videos. And the code for this will be in the description. So drop your doubts in the comments. I'll reply to everyone. So thanks for watching. I'll see you in next one.